everyone, welcome back to Learning with Haneen. As I promised my geometry students, this is the quick video going over the new changes being made to the Geometry Regents. As many of you guys know or may not know, this June 2025 Regents is based on the next generation standards. So there have been some changes made to the question types and the reference sheet, and I wanted you guys to go into your exam tomorrow feeling prepped, knowing what to expect, not to be surprised when you see the new reference sheet. So I really wanted to help you guys as much as possible. I'm going to try to keep this video very short. I apologize for speaking a lot. I just want to clarify anything that you guys may have any questions in, and please make sure that if you have any questions, I'm going to try to stay up as late as possible for any of the questions that you guys have. Please put those questions in the comments down below so I can answer your questions so you guys are ready for tomorrow's exam. So without further ado, let's get started. So this is from the New York State Department of Education in regards to the Geometry Regents, and this is the Geometry Educator Guide. In 2024 it was released, but this is for the June 2025 exam. So for this exam this year, the following are the categories that you guys are going to be tested on with their percentages. So the biggest and most dominating sections in geometry are going to be your congruency, and it's going to be congruency and similarity. So as you can see, those are the biggest and most weighted percents of the exam. So if you want to focus on studying specific things, study those congruency theorems, study those similarity theorems, right triangles, and your trigonometry. You're followed by your expressing geometric properties with equations, modeling with geometry, and the least weighted proportions are the circles and geometric measurements and dimensions. So what does this look like? So in congruency, what they're going to test you on is experiment with transformations in the plane. Can you reflect? Can you rotate? Can you translate? Can you dilate? Understanding congruency in terms of rigid motions. Does dilation preserve congruency? Are the sides the same when you dilate? Does it perform a rigid motion? Prove geometric theorems. Can you apply what you learned in terms of triangle congruency in order to prove that sections of a triangle are congruent, that two triangles are congruent, and making geometric construction. So can you perform the inscribed square? Can you construct an equilateral triangle? Can you construct a perpendicular bisector? Can you apply what you learned in these proportions and create an advanced construction that is just reliant on what you learned prior to that? For similarity, right triangles, and trigonometry, they're going to test you on the similarity in terms of similarity transformations. Prove theorems involving similarity. So as I said, your triangle similarity theorems, your side angle, your side, your angle theorems, your side angle similarity theorem. Defining your trigonometric ratios. Do you know your SOHCAHTOA? Do you know how to solve those problems? Do you understand what it means by angle of elevation? Apply trigonometry to general triangles. Remember, trig can only be used in right triangles. If you don't have a right triangle, you cannot use your trigonometric functions. For circles, you will need to know how to understand and apply the theorems about circles, so make sure you know your formulas in terms of inscribed angle, central angle, arc length, areas of the sector. Please make sure you have those memorized and you remember those. For expressing geometric properties with equations, knowing how to translate between geometric description and the equation, using the coordinates to prove simple geometric theorems algebraically. For geometric measurements and dimensions, explaining how to use the volume formulas and how to using them to solve your problems, how you can apply that, how you can visualize the relationship between two-dimensional and three-dimensional objects. And finally, for modeling with geometry, applying those geometric concepts into modeling situations. So what I do want to show you importantly is the new reference sheet. So previously, the reference sheet for the Geometry Regents consisted of many things, whereas the new reference sheet for the Geometry New Generation Learning Standards, this is what you're given. So you're only given the values of the volume. that is all that is released, and that is all that we know is going to be on that reference sheet. So definitely, previously on the sheet, there was the quadratic formula, there was conversion of radians from degree to radians, there was different conversions that are no longer on the Regents. So if there's a formula on the reference sheet that you relied on during your geometry time, look over that, make sure you have a clear idea of what it is. I'm not 100% sure if there's going to be certain questions that were relying on the old reference sheet on the new Regents. I just wanted to give you guys an idea of what that new reference sheet looks like, so when you guys go and take your exam, you are not surprised. Now, they sent out a few questions in regards to the new standards, in regards to the new question stems that they're going to be asking. So there's 8 questions, and I wanted to do those questions with you guys so you have a clear idea of some sort of the questions that you guys may be asked on the test tomorrow. So question number 1 says, triangles ABC and DEF are graphed on a set of axes below. Which sequence of rigid motions maps triangle ABC onto triangle DEF? So on this document right here, the y and x axes are not clearly labeled. So the first thing I'm going to do is I just want to make sure you guys see where the axes are. So there's your y, and this is the x-axis. The first thing I want you guys to know is to label your triangles onto how they're related to each other. So A is to D, B is to E, and C is to F. Okay, next thing, you're going to test all your answer choices. I'm going to start with the easiest ones first. So I'm going to start with the going up from down to up. So the first one says a translation 4 units down followed by a reflection over the y-axis. So I'm going to take one of my points. I'm going to take point A. So point A right here, if I translate it 4 units down, I'm going to go 1, 2, 3, 4. Well, I'm going to be here, right? So I'm going to be at, I'm just trying to make sure I'm at the right position. I'm going to be at 1, 0. I'm going to be at 1, 0. Okay? And then it's followed by a reflection over the y-axis. So when I reflect over the y-axis, I keep my y the same and I change my x. So it becomes into this. And if I look at point D, that's where I am. So, I mean, it gave me point D. But let me check my other points. So, say point C. Point C says that I'm going to translate 4 units down. So I'm going to go down 4 units. 1, 2, 3, 4. I'm now here, right? And then it says that means I'm at point 3, 4, 5, 6, 7. I'm at 7, negative 2. Okay? I'm at 7, negative 2. Now it says a reflection over the y-axis. So if I reflect it over the y-axis, I'm going to have negative 7, negative 2. And if I look, one of my points is at negative 7, negative 2, which is point E. But remember that point E does not align with point C. Point E aligns with point B. So therefore, that cannot be my answer. So if you only tested A and you see that it worked, you would say, yes, that is my answer. But that's why it's important to test more than one point whenever you're doing these rigid motions. Now, 3 says, let me just erase everything here. We have a clean slate. So, C says a translation 2 units left followed by a reflection over the x-axis. So, 2 units left, I'm going to go 1, 2, I'm going to end up being right here. I'm going to be at negative 1, 4. Okay? And then it says a reflection over the x. So a reflection over the x-axis would mean I'm keeping my x the same and I'm changing my y sign. And that places me at negative 1, 4, which would be right here, which is not point D. So I already know that's incorrect. Now, 2 says answer choice 2 says a point reflection through 0, 2. So I'm going to plot 0, 2, which is going to be right here. And now what I want to do is when I test this point reflection. So for point A, it needs to map up to point D. So to go from the point 0, 2 to point A, I went up 2 and 1 to the right. And if I want to reflect it, well, I'm going to do the opposite. So I'm going to go down 2 and 1 to the left. Okay, well, I get A to B, D. That's good. Let me keep going. For C, to go to from point 0, 2 to go to point C, I moved 1, 2, 3, 4, 5, 6, 7. 7 points to the right. So I'm going to move 7 points to the left. 1, 2, 3, 4, 5, 6, 7. Okay, I get to point F. Okay, this looks like that's going to be my answer. And then I'm going to look at point B. So point B, from the point 0, 2 to point B, I went up 1, 2, 3, 4, 5, only 4, sorry. So I'm going up, let me erase all of the other markings. Okay, I'm at 0, 2, which is right here. I'm going 1, 2, 3, 4, and I'm going to the right 1, 2, 3, 4, 5, 6, 7. So 7 to the right and 4 up. So I'm going to do the same thing by going backwards. So I'm going to go down 4, 1, 2, 3, 4, and 7 to the left. 1, 2, 3, 4, 5, 6, 7. And I end up at point E. So I know that that is my answer. So answer choice 2 is going to be my answer. Question number 2 says, in right triangle ABC below, measure of angle C is 90 degrees. Measure of angle B is 30, and CB is equal to 6 square root of 3. The length of AB is. So we're trying to determine the length of AB. So I know that this is a right triangle. So if I want to find a missing side, I know I can rely on my trig functions. Yes. So I can rely on sine, cosine, and tangent. Sine, cosine, and tangent. So for my sine, it's going to be the opposite side over the hypotenuse. For my cosine, it's going to be the adjacent side over the hypotenuse. And for my tangent, is going to be the opposite side over the adjacent. So I'm given a leg, I'm given a side, and I'm given my x, which I need to determine. So I can see that my x is across from the right angle. So if it's across from the right angle, I know my x that I'm looking for, side AB, is my hypotenuse. And I can see that the angle that I'm given, 30, the side 6 square root of 3 is adjacent to it. So I know that if I have adjacent and hypotenuse, I'm going to be using cosine. So what I'm going to do is I'm going to do cosine 30 is equal to 6 square root of 3 over x. Okay, simple cross multiplication. Cosine 30x equals 6 square root of 3, and then I'm going to divide by cosine 30, and then I'm going to get x equals 12. Answer choice 3. Question number 3 says, in non-right triangle ABC shown below, AC is 5, BC is 8, and measure of angle C is 57. What is the area of triangle ABC to the nearest tenth of a square inch? So, it says it is a non-right triangle. Because it says it's a non-right triangle, I cannot use trigonometric functions to determine the height of my triangle in order to determine my area. So in a non-right triangle, the formula that you use to determine the area is, so if I need to find the area of non-right triangle, I'm going to do area equals 1/2 AB times sine C. Okay, so what is A and what is B? They're going to be my side lengths. okay, my sides and their length. C is going to be the angle that I'm given. So if I plug in what I have in this equation, I'm going to do area of the triangle is equal to 1/2 5 times 8 times sine of 57. Okay, that's how I'm going to determine the area of my non-right triangle ABC. Okay, so non-right triangle, I need to determine the area. This is the formula that you're going to use. Okay, you're going to do area equals 1/2 AB times sine C. Sine C is your angle, AB are your sides. So when I put this into my calculator, I'm going to get 16.77341136. Because it says to the nearest tenth of a square inch, my area is going to be 16.8 inches squared. And that's going to be answer choice number 2. Number 4 says, circle P with center at 3, 2 and passing through A06 is graphed on the set of axes below. An equation of circle P is, and then your answer choices. So circle P has a center at 3, 2. So if its center is 3, 2, I can already begin part of my equation. So remember, your equation of a circle is going to be x minus h squared plus y minus k squared equals r squared. So I already have my h and my k. My h and my k are 3 and 2. So I plug that in, x, and then I'm going to leave my sign for now because I want to show you guys something. Squared plus y, leave my sign, 2 squared equals r squared, which I didn't return. So depending on the sign of your center, each coordinate, the opposite is going to be inside your parentheses. So my center is positive on both my x and my y coordinate. So inside, the sign is going to be subtraction. So I'm going to do x minus 3 squared and y minus 2 squared. Okay? Because my center was positive. So whatever inside your equation is going to be the opposite sign of what your center is. So I can already eliminate answer choices 1 and 2. Because inside my parentheses, I'm adding 3 and I'm adding 2, whereas in my actual equation, I'm going to be subtracting 3 and subtracting 2. Okay, now I need to find my radius. So I have my circle, and I can determine my radius. I can go from my center to the edge. So if I go from my center to the edge, I go 1, 2, 3, 4, 5. So I know my radius is 5 because the radius is just half of the distance. Okay, so it's 5. My radius is 5. Does that mean that that's what my equation is equal to? No, because recall that our equation says r squared. So my r is 5. I'm going to square it to get 25. So my equation is x minus 3 squared plus y minus 2 squared equals 25. That is going to be answer choice 4. Next question. Number 5 says, a triangle with vertices at -2, 3, 3, 6, and 2, 1 is graphed on the set of axes below. A horizontal stretch of a scale factor 2 with respect to x equals 0 is represented by xy turns into 2xy. Graph the image of this triangle after the horizontal stretch on the same set of axes. So they tell us we're having a dilation, a stretch, a horizontal stretch. And they tell us what that horizontal stretch means. It means that if my original coordinates were x, y, my new coordinates are going to be 2 times x and then the same y value. So I have my points. My first point is at -2, 3. I apply their rule. I multiply x by 2, so that's going to be -4, and I keep the y the same. So now my new point, my image, is going to be -4, 3, and this is my pre-image. Okay? The next point says 3, 6. I'm going to follow their rule, so I'm going to do 3 times 2, and I'm going to get 6, and I'm going to keep my y the same. The third point says 2, 1. I'm going to multiply by x, my my x by 2, so I'm going to get 4, keep the y the same, and 1. That's it. That's what they're asking for. But then they asked to graph the image. Please make sure you read the question into its entirety. So I'm going to graph my image. I'm going to zoom in just so it's easier for me to graph. And then again, I'm going to make it much more clear where my y-axis and my x-axis is. So this is my y-axis, and this is my x-axis. Not perfect, but just so I have a clear idea where I'm graphing. So my first point, -4, 3. So I'm going to go to -4, 4, and then I'm going to go to 3. 1, 2, 3. That's going to be my first point. I would prefer to label my points so it's easier for me to graph. So my original point was at -2, 3. So that was here. That was my original point. So I can call this point A. So this is going to be point A prime, because that's my image. Now, the second point, 3, 6, was right here. So I'm going to call this B. So this was 3, 6. Now it has become 6, 6. So I'm going to go to so this is going to be my B prime. Okay? And then for my point C, it was at 2, 1, and now it's at 4, 1. That is my C prime. And then I'm going to connect the points all together. Not going to be the straightest lines, but I want you guys to just get the gist of what it's going to look like. That's going to be my new triangle. Okay? So I first found out my points. I used the rule they gave me. So they give you the rule. They already tell you what you're going to do to perform that horizontal stretch. You just need to apply it and then graph it. Question number 6 says, triangle XYZ is shown below. Using a compass and straight edge, construct the circumcenter of triangle XYZ. So, circumcenter just means the intersection. Oh, let me make that look much more thicker. It means the intersection of the perpendicular bisectors of each side. So the point of intersection where each perpendicular bisector, when it's formed on each line, the point where they intersect, that's going to be your circumcenter. Okay? So I'm going to show you how to do that. So I have my triangle, and then I'm going to put my compass on my first side. So I'm going to do it at X, and then I'm going to stretch out my compass so that it's more than halfway through, and then I'm going to draw my arc. I'm going to keep my distance the same, and I'm going to go to my other point, point Z, and then I'm going to draw my other arc. So see, I have to redraw my first arc because it was not large enough. Go back here. And then draw it once more. Okay. And then I'm going to draw my straight line through the intersections. Scroll down so you guys can see what I'm seeing. Okay, so there we have it. And then I'm going to perform another perpendicular bisector on the other line. So I'm going to put it right here. What have for me to change the compass to make it look different? Okay, so can I? Oh, there it is. So I have my compass. I'm going to stretch it out greater than half the distance, right? I'm going to draw my first arc. Okay, and then I'm going to place it again. I'm going to flip it and do the same thing on my other point right here. It's not going to be as neat and as yours will be on the Day of the Regents. I'm just trying to give you guys an idea of what the question means. So, and there we go. That's my intersection. I'm going to move my compass here. And then my point of intersection, so I have a point here and a point here, and then I'm going to draw my straight line through both points. Okay. And then I'm going to perform the last perpendicular bisector. I'm going to go to point Z, right here, and then I'm going to draw my arc. Oh, don't change the distance. And then I'm going to flip it, and then draw the same arc on the other side. Let me do that again. Now that's all done, and then I'm going to draw the last line from, you gotta make sure, from right here. What in the world? Right here. Oh, do that. And draw my point from here to here. Okay? And then your circumcenter is going to be this point right here, where they all intersect, all three perpendicular bisectors. So it's the point of intersection of the perpendicular bisectors. Okay, so that is how you perform the circumcenter. Okay. Next question. Question number 7 says, in the diagram below, triangle ABC is similar to triangle DEF. If AB equals 4, BC equals x minus 1, DE equals x plus 3, and EF equals 15, determine and state the length of DE. So, what I'm going to do is, I'm going to first label my triangles. So, the first thing I'm going to do is I'm going to label my triangles. So, it tells me that AB is 4, tells me that BC is x minus 1, DE is x plus 3, and EF is 15. And I'm told that my triangles are similar. And if the triangles are similar, I know that my sides are proportional. The corresponding sides are proportional. So, and they want me to determine and state the length of DE. So if I know that the length of my sides are proportional, I can write a proportion. So I can do side AB to BC is equal to side DE to EF, which would look to be 4 over x minus 1 is equal to x plus 3 over 15. And when I cross multiply, I'm going to get 60 equals x squared plus 2x minus 3. Okay, just simple FOIL. X minus 1, x plus 3. Okay, just a simple FOIL. Now, what I want to do now is I see I have a quadratic, so I'm going to factor. I'm going to subtract 60 on both sides. I'm going to get x squared plus 2x minus 63 equals 0. So I need to find two factors that when multiplied give me negative 63 and add to get 2. Well, that's going to be 9 and 7, but I'm going to have negative 7 and 9. So then I'm going to write them out into my parentheses as the binomials. So x minus 7 and x plus 9, and set that equal to 0. And then I'm going to do x minus 7 equals 0, add 7 to both sides, and I'm going to x equals 7 on this side, and then I'm going to write x plus 9 equals 0, subtract 9 on both sides to isolate x equals negative 9. So I know that these values of x are for side length, and I know that sides cannot be negative. So I'm going to not use x equals negative 9. I'm only going to focus on x equals 7. So they asked me to find the length of DE, and they told me that DE is x plus 3. So I'm going to substitute in my value of x, which was 7, so 7 plus 3. So, and then the value of DE equals 10. That's it. Question number 8, and this is the last question that we're given. Hexagon ABCDEF with coordinates at A is 0, 6, B is 3, 3, C is 3, 1, D is 0, negative 2, E is negative 3, 1, and F is negative 3, 3 is graphed on a set of axes below. Determine and state the perimeter of triangle ABCDEF in simplest radical form. So in order to determine this, I need to know the side length of each of these sides of hexagon ABCDEF. So I already know the side length of FE and BC. So this and this are each 2. Okay? But now I need to determine the value of AF, AB, CD, and ED. What I'm going to do is I'm going to inscribe my hexagon into a square. So when I inscribe my hexagon into the square-like shape, what I'm going to form is I'm going to form 4 different right triangles. So when I form these right triangles, I can determine the length of the sides because I can use the Pythagorean theorem. So how do I do that? Well, first of all, I don't need to solve for all 4 of them, because they're all congruent. They're all equal to the same distance. So what I'm going to do is I'm going to take triangle number 1. So it has a side length of 3 by 3. So I'm going to use my Pythagorean theorem, a squared plus b squared equals c squared. I know my a squared is 3 squared, b squared is 3 squared, and c squared is the length of the hypotenuse that I'm trying to find, which is the side that I need for my perimeter. So then I'm going to do 9 plus 9 equals c squared, so 18 equals c squared, and then square root on both sides, c equals square root of 18. So the length of AF is square root of 18, but it's also the length of ED, the length of AB, and the length of CD. So to make it easier on myself, I'm just going to do 4 times square root of 18, and I'm going to get 4 square root of 18 as the side length of the 4 triangles that I was trying to find. And then what I'm going to do is I have 4 square root of 18 plus 2 plus 2. And that simplifies to 4 square root of 18 plus 4. Some people would have the tendency to say, I'm done. You're not done. Because the question says, determine and state the perimeter of A, B, C, D, E, F in simplest radical form. So that means that inside the radical, it is not simplified. So if I look at my square root of 18, I think of 2 numbers, one of them that is a perfect square, and when multiplied together give me 18. Well, I can think of the square root of 2 and the square root of 9. Square root of 9 is just 3. Square root of 2 remains the same. So what I'm going to do is I'm going to end up doing 4 times 3 square root of 2 plus 4. And this simplifies to 12 square root of 2 plus 4 as your final perimeter of A, B, C, D, E, F in simplest radical form. So that is the end of the questions that they provide in regards to the new changes that are being made to tomorrow's Regents examination. If you have any questions about any of these problems or any of the other problems, please feel free to let me know in the comments down below. If you've watched the end of this video and you have not yet subscribed, please be sure to subscribe, like, and share with all of your friends, and good luck on tomorrow's test. I'm sure you guys are going to do great, and please update me after you guys take the test. Have a good day and good luck.